also going to record this session, so I hope that that is okay with everyone. So the Konrad Adenauer Stiftung is going to make a recording of this session. And of course, it's also very nice if you choose to turn on your video so that we can see each other, particularly if you are going to speak. It's very nice, but also for all participants, it's nice to see who the others are. And there you have, I see most people have written their names very nicely when they have been logging in to the Zoom meeting, but it's also possible to go and rename yourself if you notice that you have just used some kind of acronym or so. You can click on participants and then find your name, and then on your name you click on your name and then rename, and then you can rename who you are. I see that right now we have about 40 participants. That's very good. So I think that we relatively soon will start. I'm just checking here if there is anything more I should think about before we start. We do have 3 presentations today. The first one is by Mr. Sajith Edirisuriya, General Manager of Chinkin Corporation. Actually, I think it's the ship Mong Ecocycle that he's the General Manager of. And he will talk about large-scale industrial waste management solutions through cement kiln co-processing, sharing the experience of best practices through case studies in the Cambodia industry sector. Then we have Mr. Sebastian Frisch, German expert from BlackForest solution. He is a consultant working on different waste management solutions in different countries in the world. And he's going to talk about how does Germany use waste to make energy. And then there is going to be a video. And after that, we will have Mr. Marc Loskarn, who is a mechanical biological treatment projects engineer for EUWELLE environment, and he will talk about technology transfer of the, let me see what the acronym, the maximum yield technology. Process development in Germany to a technical facility in Southeast Asia. So the agenda for the day, and then afterwards we will have a Q&A session. So is there anyone that would like to say something or add something before we start? Please let me know. I don't see any hands and nothing in the chat box. So then I think we will just go to the first presentation. So Sajith, over to you for your presentation. And I have given you the possibility to share your screen. So I suggest that you share the screen yourself, and then you can steer it. Please, Sajith. We do not hear you yet, Sajith. I don't know if you have unmuted yourself or not. We do see your screen. Maybe talk again. Maybe it was just me you didn't hear.
Hello.
Now I heard something.
Yeah. Okay. So you can see my presentation now.
Yes, we can.
Okay.
So you can please start.
Yeah. Wait. Just I think some technical issues. I cannot have the full screen. That is the issue.
Maybe if you
Okay. Thank you very much. So now you can hear me and you can see my presentation, right?
Yes, we can. So very good.
So sorry about that. Good afternoon to all of you. Thanks for having me for this valuable session. So thanks, Leif, for the introduction. So today I'm going to present about the large-scale industrial waste management solution to cement kilns composting. You can see right-hand side, this is our plant, Mong Insee cement and waste processing plant at Cambodia. Let me introduce briefly about the company. Chipmong EcoCycle is a business unit of Chipmong Insee Cement Corporation. Basically, it's a joint venture between the Chipmong Group and Siam City Cement. And EcoCycle is basically the waste management arm of the Siam City Cement, which they operate in Thailand. EcoCycle is operated in Thailand, Vietnam, Sri Lanka. Now newly they joined as a sister company. So basically, most of the people in Cambodia knows about the Chipmong Group because Chipmong Group is one of the well-known diversified conglomerate which are doing like a business in the banking, retail sector, steel, hotel, beer, you name it, most of the area they are there. So Siam City Cement is actually the cement regional cement player, which they operate in several countries. Most of the countries that they operate, they are in the number 1 or number 2 in the market in cement, as well as in the waste management. So so most of the people knows about this waste management hierarchy. Therefore, I'm not going to discuss about the waste management hierarchy. What I want to emphasize, waste management hierarchy, we can divide into the mainly 2 areas. One is the solution. We can divide into 2 areas. One is actually recovery solutions, and other one is the disposal solutions. Basically, most of the people like to go to the desirability is to go to the top of the waste management hierarchy. Those are the recovery process, and then after that, down the line, you can see the disposal process. And if you look at in Cambodia, even we don't like or not, most of the waste are unmanaged. So in our solution, basically we are saying as a co-processing, cement kiln co-processing, it is a recovery process. It is 100% we can recover the material and energy. Therefore, it's a recovery process, and it's not only the waste to energy, actually, it's a waste to resource. We can recover the material also. I'll detail explain about the core processing. Before explain the core processing, you can see the right-hand side of the slides. There are some pictures. In the top side, you can see the cement kiln, right? This is the main equipment that they're using to dispose the waste, right? So the down in the right-hand side down, you can see the layout of the cement kiln. So this is actually the cement kiln is the heart of the cement manufacturing process and waste management process, waste disposal process. So what is the co-processing? Co-processing basically means we are doing two activities simultaneously without compromising any activity. That means we are producing the clinker, which is the semi-finished good of the cement, and on the same time we are disposing the waste at the same parallelly. That is called the core processing. So cement kiln is one of the perfect infrastructure to dispose the waste, even the most hazardous waste also. Why? There are two main of the cement kiln. One is a temperature, other one is the residence time. So temperature, if you look at in the cement kiln layout, you can see in our main burner in here, we have like 1,800 to 2,000 centigrade of temperature, which is in the layman term 1/3 of sun surface temperature, and inside the material temperature 1,450, which is I think quite. If you compare with the incinerator, if I give the numbers 800, 900 centigrade, some incinerators are 1,100. So if you compare with that, in the cement kiln has a much higher temperature, which is a perfect environment for the waste disposal. And second thing is the residence time. Basically, if you look at here, our gas residence time is 6 to 7 seconds, and material residence time is 30 seconds. So normally in the European guidelines and things, if you look at, it's like if in this temperature, if you expose to 2 to 3 seconds, even hazardous material also can dispose. Therefore, we are having a higher residence time in our design. And on the same time, you can see 30 minutes the material residence time. You can see in the cement kiln, this cement kiln is 72 meters, length is 72 meters, and the diameter is 4.25 meters, which is actually supply 25% of the Cambodia demand, cement demand, right? So therefore, from this corner to this corner, from the kiln that one corner to the other corner, it takes like 30 minutes to go to the material from that corner to this corner, which that means which expose the temperature. And due to these two features, actually we can say we can guarantee that 100% destruction can happen in the cement kiln. And other thing is with this specific temperature profiles, we can avoid the dioxin furans, right? Even with higher temperature of this in the combustion stage, yes, there's no dioxin furan. We can avoid the dioxin furan formation. On the same time, the post combustion also due to the residence times and as well as the kiln design, basically what do you call it? It's like there's no sudden cooling, so we can avoid the dioxin furan. Another beauty of this technology, basically there's a zero residues for landfill. I earlier also mentioned 100% material recovery, 100% energy recovery is there. On the same time, if there's any small ash, that will be an ingredient of the cement clinker, which is the main semi-finished good of the cement. So therefore, there's a zero landfill process, and it reduces the greenhouse gas also, because if there's a I already mentioned about energy recovery. Therefore, we can replace some of our fossil fuels. So therefore, if we burn the coal, then there will be the CO2 emissions. So therefore, here we can avoid some of the coal consumption. And another important thing is most of the waste management solutions are the small scale waste management solutions. If you look at the cement kiln, actually in our cement kiln, we can dispose 30 tons per hour. Design, we can have 30 tons per hour. At the moment, we have design only for 10 tons, but we can upgrade to 30 tons per hour, which is a huge volumes. That means more than 200,000 tons of waste we can dispose. And other thing is alkaline environment and self-cleaning process. If you look at this preheater, 5 preheaters, if you can hear, there's alkaline environment is there, therefore it works as a scrubber, and they scrub in the acidic gas like HCl, SO2 and things. So this is about the co-processing. So if this is the actual picture of our plant, there are 3 main areas that we are using to dispose the waste. One is actually why we are using 3 main areas, because based on the characteristics of the waste, chemical characteristic, we are using 3 different places. One is actually raw material preparation area, and other thing is the preheater cabina, and other thing is the main burner we are disposing the waste. So this is actually about the emissions reductions by co-processing. Basically, here I'm going to show some hypothetical scenarios. One is actually, it's a conventional approach. That means if the cement kiln is not using the waste, then what happens is there should be a waste incinerators to dispose whatever the waste. So it has emissions, and finally there will be residues also. You can see it has emissions, and there are some residues also can happen. Example, it depends on the incinerator, 10%, 15%, 20%, whatever the amount, there will be a residue. On the same time, the cement manufacturing process also should be there, because in the life, for the development, for our day-to-day life, cement is a necessary product. Therefore, cement manufacturing also should be there. Another thing is, I think, apart from the water, second largest consumed material is the concrete, right, in the world. So therefore, cement has to be there. And cement manufacturing process also, there are emissions are going. So finally, cement will come. So what we have done is basically we have integrated these 2 into the one process, and then we are calling it's an integrated approach. And what we are doing is some of the waste which we can use which we can get the energy, so then we are replacing some of our fossil fuel, right? On the same time, we are keeping our emission limits within our cement manufacturing guided emission limit. On the same time, one of the beauties in this process, there's no residues. And this cement kiln co-processing for the Cambodia is very new. We are the first people who have started, but in the world, it's very well-known technology. Even US, Europe, Japan, whatever South Asian countries like Thailand, Vietnam, Malaysia, Singapore, Malaysia, likewise, all these countries, they are doing this, right? So it has been recognized in the European Union, Basel Convention, Stockholm Convention, United States Environment Protection Agency, likewise. On the same time, in Cambodia, we got the license from the Environment Ministry to handle all the industrial waste in Cambodia without any location in Cambodia. So if you look at what are the waste that we can co-process? Actually, at the moment, we have capacity of 75,000 tons, which we are going to increase further in next coming years to double these volumes. From the non-hazardous waste to the highly hazardous waste like a PCB waste, which we can dispose. That means if you give the industrial waste, 90% of the industrial waste which we can dispose from our solution. Right. So now I just explain because I can remember 2019 October also, Congress had their second waste summit. I have presented our solution. At that time, it was under construction. So then after that 2019 December, we were implemented our solution, and within 10 months of the operation, we have done a lot of things. One thing is we started with the biomass and things, and then after that Within 1 month, we started to give solution for non-hazardous waste like a garment. In Cambodia, 70% industries are garment and footwear industry. Garment and footwear waste, we started to dispose. On the same time, there was one of the main issue in the Cambodia. Basically, there's no fee for the disposal of the secured disposal of the branded waste, like a branded FMCG product, branded shoes, branded garments and things, which we are giving the solution for now, those things. On the same time, within the 3 or 4 months, we realized that we required to increase our capacity of collection and storage, and then management decided to invest further. And on the same time, originally our plan was to start the hazardous waste within 2 years' time after start the operation, but we were able to start the operation with our all competent people. Within 6 months of the operation, we were able to start the hazardous waste. From that also, we are catering to the one of the biggest sludge generator in Cambodia. And on the same time, we were able to give the solution for the one of the biggest pharmaceutical disposal of 425 tons. And then in July, actually, we have signed the contract with the Cambodian biggest special economic zone in Sihanoukville to give the solution for them. And now we are building our collection facility in there. It will come sooner to the operation. And in the September, actually, we were able to have a highest hazardous waste disposal, more than 350 tons of hazardous waste. If not, this will be landfilled or this will be going somewhere else. So we are proud about our journey within 10 months. So as a result of that, we have more than 30 factories we are working with us. And we were able to replace fossil fuel by 10%. And 30,000 tons of waste we have disposed. And on the same time, we have reduced the 36,000 tons of carbon dioxide. And actually, for this particular 1.5 year period, we have invested more than 5 million only for the waste management business, apart from the infrastructure in the cement plant. So that is about our journey. So I think that's about the eco cycle. Thank you very much for the Congress to give this opportunity for us to show some successful business case. Leif, over to you. And if you have any question, you can ask.
Thank you so much, Sajith, for a very clear and concise presentation. Is there any direct questions or on clarification? Otherwise, we will have more of a question and answer sessions after all the 3 presentations. But if there is something that just needs an immediate presentation, please raise your hand or write something in the chat box.
Can I have one question, please?
Yes. Who is it that speaks?
Udam.
Okay, please go ahead.
To the speaker, can I call you Surya? Surya?
Yeah, Edirisuriya, yes.
Yeah, so
you can say it, Sajith.
Oh, okay.
Sajith.
I heard you mention about working with the garment and footwear industry. I'm wondering if you work with them at the place outside Sihanoukville, Kampong Spur, because we have the industry outside just Sihanoukville or Sweden at Babat Industrial Zone.
Yeah, basically, actually, we are working in everywhere in Cambodia at the moment. At the moment, we are working Babat. We are working Kampong Spur, Phnom Penh, Sihanoukville. Everywhere we are working. So because we are working with Adidas factories, and we are giving the zero landfill solution for the Adidas factories. They are in everywhere. Likewise, there are a lot of factories we are working with. Phnom Penh Economic Zone we are working, Sihanoukville Special Economic Zone we are working, Babat Special Economic Zone we are working. So at the moment, but we are making one collection center in Sihanoukville because we are going to give solution for the 160 factories.
Okay, okay.
That means
I'm working with garment and footwear factories also. So there, yeah, it's nice that we meet each other. Good thing.
yes.
Thank you. Then, so just to update everyone, if we have anyone who has entered this summit meeting in the middle of the presentation. So this is the Waste Summit 2020 that is ongoing. This is a session on waste to energy. And we have just listened to our first presentations, and we have 2 more presentations. And I should just say that on behalf of the organizers, I'm very pleased that we have so many participants. So now we will go over to the next presentation, and this is Sebastian Frisch, who will talk about how does Germany use waste to make energy, and give us some experiences that he will share to us. So the floor is yours, Sebastian.
Thank you, Leif. Thanks for this kind introduction. I hope you can see me all and you can see my presentation.
Yes, you can put on the full screen down at the bottom. Yes.
Yeah. All right. Yeah, and also thanks from my side, from our side as BlackForest Solutions, to give us this opportunity to present today. Don't be confused, please, about the Arabic subtitles. We are quite active in the Arabic region. That's why you may see there are some subtitles at the moment. I'm also currently based in the UAE, but we are, and I will tell this in a minute, a waste management consultancy that acts globally and in different waste sections, in different waste fields. Today I'm going to speak about how does actually Germany use waste to make energy, what are the possibilities there, and what are the challenges, and also to bring it into a context, why does some technology may work in Germany, and what are the specific challenges, especially in some Asian countries, when it comes to utilizing the energy out of waste. So we have, as BlackForest Solutions, we have 2 main pillars, 2 main activities. One is trading and operations also. There we are using the Basel Convention that was mentioned by Sajith before. Basel Convention is about the transboundary shipment of hazardous waste when in certain treatment technologies for hazardous waste, then there is a chance to use the Basel Convention to export the hazardous waste into countries where there is a treatment opportunity for hazardous waste. And clearly, as mentioned by Sajith, the cement industry is one of the potential receiver also of hazardous waste, as we just learned in the presentation for. So this is one area where we are active also on site with so-called in situ operations, where we do hazardous waste and waste assessments, decontamination, repackaging, and we also do the whole licensing and notification management. And the second part is consulting, indeed, where we consult on a more technical level, technical waste management projects, but we also consult on financing these projects and on the implementation. We would be, for example, also one point of contact when it comes to finding investors, or when there are difficulties to implement actually concepts and strategies in countries. When we talk about Germany, what is at the moment, this data is a little bit old, from 2014 in Germany, but then in Germany that has not changed too much. There's a bit of an increase of generation, but we speak roughly about 350, 380 million tons of waste that is generated in Germany. And out of this 350 to 380 million tons, most of it, as you see, is the so-called C&D waste, which stands for construction and demolition waste. So only a rather small part is municipal waste, that you also know as household waste. We're talking about roughly 50 million tons. In Germany, we have rather high recycling. So also some figures are varying there, but speaking between 65 to 70% of recycling in Germany of the household waste. The hazardous waste has about 17 million tons in Germany. And what we always like to say also, waste management in Germany is not just bringing or collecting waste in a bin and bring it with a compactor to a landfill, and that's it. It's a whole circular economy, and I have to say industry, right? Because there are more than 270,000 people employed in waste management, in a direct employment with waste management solutions. And the annual turnover in Germany for waste management companies is about 70 billion euros. When it comes to the different plants that has been installed in Germany, we have currently 15,500 plants just dedicated for the treatment of. When it comes to waste to energy, then it is to highlight that there are 161 classical waste incineration plants. We have 687 waste to energy plants. When you look at the acronym MBT here, that stands for mechanical biological treatment, then we have 55 plants. And this is also related to Sajith's presentation before. In this MBT, the so-called refuse-derived fuel is being generated. So this is what the cement industry can take, can buy in some cases, and use as an alternative to their primary fuel. Yeah? So most of the cement kilns, they use fossil fuel as their main energy source, but it is very important to substitute these fossil fuels by alternative fuels. And the one that has the best opportunities also to grow is waste as a refuse-derived fuel. Yeah, so waste used as an alternative fuel instead of, for example, coal or diesel. But you see also in these numbers that there's a huge activity in Germany's circular economy and waste management. When we see what is the current consumption in Germany in terms of energy, yeah, you have, when we're talking about energy, we have to distinguish between electricity and heat. And the unit there that is mostly being used on a state level, on a country level, is gigawatt hours. And the total energy consumption, when you just look at the electricity, in Germany we have about 615,000 gigawatt hours back in 2010. So also a rather old figure, but it has not changed too much. So the energy consumption in Germany is rather stable in the last 10 to 15 years. So to give you a rough figure, yeah, 615,000 gigawatt hours for the electricity. And then you see actually this split which technology of waste to energy is contributing with which gigawatt hours. So for example, all the RDF power plants in Germany combined are producing more than 1,000 gigawatt hours. The co-incineration from the power plants generates about 2,800 gigawatts per hour. And if you sum up everything, then in Germany we have from waste to energy about 22,000 gigawatt hours electricity as a contribution. And when you compare this now with the total energy consumption in Germany, then you can say that around 3 to 4% of the consumption in entire Germany is generated by waste to energy technology and waste to energy concepts. Just as a side remark, it was quite difficult to find exact data for Cambodia. I found one on a platform called worlddata.info. So this is not really confirmed from our side, but there it is said that Cambodia is using or has a demand of about 6,000 gigawatt per hour. So Germany has about 1,000 times more energy demand or energy consumption in Germany compared to Cambodia. But this figure needs to be double checked, please. And a few words also about where we had positive experience in Germany. This is especially with this RDF, refuse derived fuel, and especially since 2005, where in Germany the closure of landfills were decided by law for all untreated waste. So there was no landfill possibility available in Germany, and German waste management needed to be creative and innovative and started to develop, especially on this RDF, refuse-derived fuel solution. And also Chipmunk, Sajith just mentioned the substitution rates. And in Germany, you have currently in 2020 a substitution rate of more than 50% in German kilns. This means more than 50% of the energy sources for German cement kilns are waste sources, or waste as a feed material. And you have from all the large cement kilns like Insee or Lafarge Holcim or Heidelberg Cement, you have global substitution rate targets. So we see that even in remote areas, and I can speak again here for the Middle East and maybe in Iraq, they also have very ambitious targets how to substitute fossil fuel by RDF. And very important, hazardous waste company. Hazardous waste can also be used as an RDF, as mentioned before by Sajith. So very pleased to hear that now around 400 tons per month of hazardous waste is being treated in Cambodia in a cement kiln. Why it's still challenging when we think about other waste to energy solutions, especially for certain, there are challenges when it comes to classical typical waste to energy facilities. One is that you need always a high calorific value of the waste. And if you just have a single bin of organic waste, so kitchen waste, food waste into it, then the calorific value decreases and makes it difficult to implement a waste to energy facility. Normally you should have a small influence of the so-called informal sector, the waste pickers, but unfortunately or fortunately, depending on the perspective, in Southeast Asia, you have a strong influence of the informal sector who is picking especially plastics, paper out of the waste. And this plastic is what normally contributes to the calorific value. Also, when you operate waste to energy facilities, you need, as an operator, rather high so-called gate fees. So this is the tipping fee that must be paid by the company that brings the waste to the facility. And also you have rather high capex, so investment expenditures. And because of all these factors, especially waste to energy with great firing yeah, typical classical burning of waste is rather difficult to implement because of these reasons in some Asian regions. And also the same applies for biogas from food waste with similar challenges for some Asian countries. The question is whether this can be properly combined with RDF, with refuse-derived fuel. And as a next presentation, we will see one successful business model where this actually happened, where in Thailand. Yeah, this will be presented by the company EUWELLE, where you have a positive example of combining actually refuse-derived fuel with a huge amount of food waste that we have, especially in Asian countries. Here's a short overview about the actual business model of the most successful waste-to-energy technology and model also in Germany, because we really think that especially this one can be also implemented in Southeast Asia and Cambodia. Not only for cement plants, but also for coal power plants. That would be very interesting for paper mills, or in general for all energy intensive industries. But we need to be aware about the costs, and also we need to double check the revenues that are there. You see some pictures of RDF, how it actually looks like. There's pressed RDF on the left side of this picture, and the right side shows some fluff RDF, which is cheaper to generate. The questions that needs to be solved for RDF, and also I think you would agree, Sajith, from the cement factory perspective, there are some uncertainties regarding supply and quality of RDF. A cement kiln actually produces the cement as a product, right? It's not originally a waste treatment facility. It manufactures something with very specific acceptance criteria and quality expectations. And waste does not always have this. How to solve the capex issue, how to mobilize investors. Logistics can be a big issue as well in certain areas. And not to forget what happens if we still have landfills. Yeah? Whenever you have a landfill, then it's always easier and cheaper just to dump things, just to dump waste, rather than using advanced technology. And in Germany, it all started only after 2005, where we banned untreated waste going to landfill. So this may be the contribution from our side for time being, and also looking forward to a dialogue, not even today, but for the whole week of the Cambodian Waste Summit. Thank you very much.
Thank you very much, Sebastian, for a very interesting presentation. I think that we can move directly further to the next point. So I think we were going to have a video, and is it Marc? Is it you going to show the video, or is it somebody else who controls this?
It's me. First of all, hello. I just wanted to say that I'm showing the video at the end because I want to explain the technology, and then give like a virtual plant visit just for the end, and which makes it way easier to understand. And I think that's like a good ending point then.
Okay, thank you. So just to give you a proper introduction, Marc, our third speaker is Marc Loskarn from EUWELLE, which is a German company, and you will talk about this maximum yield technology. So welcome. The floor is yours, and just if there's anyone who has just logged in here, this is the 2020 Waste Summit, and this is the Waste to Energy session that we are in the middle of. So please, Mr. Loskarn.
So, thank you for the good introduction, and thank you also for the already done presentations of Mr. Sajith and Sebastian Frisch, which is perfectly the basis where to start for me, because our technology is also aiming for the production of RDF and for products for the cement industry. So this was already a good basis here to start with. Just a brief introduction of EUWELLE. We are a subsidiary of the WELLE Environmental Technology Corporation in China. And we are based in Germany, and we are responsible for Africa, Southeast Asia, and Europe projects of mechanical biological treatment projects. So, just to give you a brief overview, today I will tell you about a brief introduction of maximum yield technology. And as I said, I would end this presentation today with a 10-minute video of a virtual visit of the MYT plant in Germany. This is on the basis then for tomorrow, as we are also using this technology in Bangkok, where the waste is, as Sebastian already said, very different. So the Asian waste is way higher in organics and much more wet. And the second part tomorrow, a case study of mechanical biological treatment technology. The case study will be a project from us in Egypt. So this is a little bit less technology, but still very, very effective to produce RDF in different countries. So just a background of the MYT technology in Germany. The technology, so the plant serves the waste from around 600,000 residents in Germany, which produce 100 kilotons a year. Just to have an impression of the capacity. And it's the operator is called ZAC, so it's the Special Purpose Association, and the MYT business unit is responsible for the know-how transfer, and we as EUWELLE are also working for the MYT business unit, just to understand the connections here. The location in Germany is here in the southwest of Germany, as it is close to the French border. So we are also serving some amounts of French waste, which is overproducing in France. As Sajith already showed, here is the, I think, well-known waste hierarchy, with the least preferred technology of landfills, of sanitary or unsanitary landfills, then energy recovery, only energy recovery without material recovery, and for at least for the organic waste hierarchy, here we have the anaerobic digestion with biogas production and RDF production. So this is here in this hierarchy the best preferable. The plant I will talk today about is the first maximum yield technology plant. It was built in 2006 and is running since without any unplanned downtime. So this is 14 years of perfectly going technology. And tomorrow we will talk about here the fourth plant, which is built from our mother company, and it has the capacity of the plant I'm talking today about. So here you see a top view of the area of the MYT plant, and just to give you a orientation, the waste, so the municipal solid waste here is collected without separated collection of organic waste. So this is a special case here in Germany. Usually you have separation at source. You know, Germany is like world champion in waste separation, but here we don't need that, because our technology aims also on the production of biogas. So we need a high load in organics here, which makes it way easier also for the municipalities, because they have less logistics and hence also less costs. So the waste is arrived here in the arrival hall, called Hall 1, of course, and is then shredded and put here into the mechanical pre-treatment hall. Here it is sieved, and the plastics, so the high load plastics, and the organics, which are the smaller particles, are separated by sieving, so mechanically. The overflow, the high load plastics are here already shipped away as RDF for different plants, energy plants, and the organics are then sent to here to the biological treatment. Here the high load organics are washed in a reactor which is called the multiple zone reactor, and the separated liquids are then put into an anaerobic digestion tank, which produces biogas, and the residual solids which are pressed out are then put here into biological drying units. So here is still a bit of organics in there, but also lots of high calorific particles, like small plastic fractions and particles. And here it is biologically dry, increases the calorific value, and this can then also be sold as RDF, or with further treatment, it is also possible to gain soil improver or compost. These are the 5 steps. These will be explained in detail in the video, which I will show you. It is just important to know that here in Germany, it's like the full spectrum of what is possible here, to best quality of RDF and biogas. And tomorrow I will show you, because the conditions are different, and also the requests of our client are different. We were able to leave out step 4 and step 5 in Bangkok. So this is not just a strict construction which only works like this. This is pretty variable depending on clients' demands. The special is the so-called multiple zone reactor, because here you the organic fraction, the high organic fraction, is put into the reactor and then mixed together with process water. So there is a ratio in between 1 to 2 cubic meter per ton of water, of input. Water is percolated into it, and within the retention time of 2 to 3 days, there is a hydrolysis occurring here, which makes the organic fraction water soluble, and it's like a first step of digestion, that it breaks down the organics into organic acids. which are water soluble, and then we put it into the anaerobic digestion tanks. So this is AD, and it's way more efficient to make it like this, to separate the solids and the organics into the liquid way less, and the waste time yield is higher than here. So this looks then like this. So here we see, as you can see, it is fully closed here. These are the mixers, the MZRs, and here are the presses. So the waste is coming here, and at the end they are pressed, and this here, the separation of solid and liquid occurs. So the liquids are sent to the anaerobic digestion tanks, which you can see here, and you get a more or less homogeneous sludge, which can be then, and this looks then like this. You see these are pretty large boxes here, and with time of 10 days, they have then to get specific requirements which are demanded by, for example, cement industry or paper industry, which need a good flowing material to be use it for their incinerators. As Sebastian and Sajith already said, RDF is of high importance, especially for cement industry, because you use everything, so the thermal energy and the material. So it's depending on definition, material recovery. And here we made a comparison, our RDF. So this is the average of our three qualities, which is then here, and paired it with coal, so with lignite, not hard coal. And you can see we are pretty comparable with all of our values, except of bioorganic carbon, because we are obviously here in high organics, and the ash content. We have here a higher ash content, but these more or less negative value is not as important for the cement industry, because they built in all the material. So this is, I hope you can say it too, Sajith, that this is more or less neglected for the cement industry. And here, for a mass balance of our methodology, you can see here from 100,000 tons per year, we produce 38% of RDF. So this is like high, middle, and low calorific RDF. We produce 5,000 tons of biogas. Then obviously we have a lot of processed water, which is treated biologically in our facility. Then we have mineral materials, which are sent back to landfill because they are inert, or they are used for the buildings of street. And we also have metals, which are then sold, of course, and a few losses and residual materials. So you see, we have here the usage of over 90%, 90 to 95% we are able to use here from the waste. For the energy balance, you can see here, this was a calculation which we made, which is comparing the theoretically available energy here in the waste, if you really use everything, and using from it. So you can see within the RDF, we have And as biogas, we are around 85 to 87%, which we can sell as energy. And the own use is only 11% of the total. So we have a total energy overproduction of 75%, which we can sell as solids or the biogas into the grid or biogas grid, or directly converted to power via CHP, and then sell the energy. And like this, we are obviously we are obviously decreasing the CO2 production in all of our clients' plants. So cement plant, as it was already told, because RDF is a substitute for fossil fuels, and also with the methane, so fossil methane supplements, and also paper plant, and every industry that is high demanding energy. Yeah, and as a summary, the MYT technology, so maximum yield technology, is effective for the reduction of waste amount to be landfill, because we're reducing the amount up to 95%. It is a prevention of landfill gas, of course, because we are producing the methane, so the biogas, in controlled conditions, and collect it, and then CHP and power plant, or directly feeding it into the local grid. And like this, it's ecologically and economically. So this plant in Germany, and also is really gives gains sorry does not it keeps itself alive financially, so you get revenues from it. So this was the theory for it, and I just want to, so that you can better imagine on like there, and if it's dirty, what products are there, how are the products look like. I want to show you a video which is also available on. So I am not sure if this works quite good with the connection. So I also put already the quality on the lowest level. I hope you can still see it. If you are interested in it, you can also just use the link, or go to our YouTube channel and have a look on it. Then you can see it on best quality, of course. So this video is it's just for your information.
Nowadays, we're using more and more finite products as raw materials for production and
just a question, can you hear the sound? Perfect.
Energy supply. These products can also be found in, of all places, our rubbish. The Holmberg Waste Treatment Association, ZAC for short, has managed to use waste as a resource and to extract the maximum of energy potential and raw material from household waste. Through the use of the innovative maximum yield technology, the association's mechanical biological waste treatment facility works reliably, is self-sufficient in terms of energy use, and has almost no emissions. The end result is that high-quality raw materials and energy sources are generated in the form of economically useful products from over 100,000 tons of waste each year, thereby making an important contribution to the conservation of resources and the prevention prevention of climate change. MYT consists of 5 tried and tested, perfectly synchronized process steps. The first step is the intake of waste. The delivery hall. This is where the waste begins its journey through the MYT facility, and the last point at which it can be plainly seen. The grabber loads 2 conveyor belts equally with the waste that's been delivered and sorts out large impurities and recyclable waste. The checked waste then proceeds in metered quantities to step 2, mechanical processing. Here, the waste is automatically separated according to material type and differences in size. The concepts and systems used are based on the ZAC's many years of experience and guarantee safe operation and the systematic separation of fuels, minerals, metals, and a small amount of non-recyclable residual waste. The checked and processed waste then proceeds to the third step of the process, the biological stage. In the intensively tested multiple zone reactor, MZR for short, the waste is selectively reduced in size and homogenized using a horizontal agitator. Processed water is added as part of a cycle, thus ensuring appropriate, unchanging consistency. After being in the mixer for a short period of time, presses are used to separate water from solids. A portion of the microbially assimilable organic material is washed out with the resulting press water, then purified several times, used to generate energy. The water treatment. MYT incorporates a practice-proven and mature water treatment process. The processed water from the biological stages is mechanically and physically processed to separate coarse and fibrous materials. Microorganisms living in biogas fermenters create biogas from organic compounds. This biogas is then used in the nearby cogeneration unit to generate electricity and hot water for the local district heating network. In the process, more electricity and heat is produced every year than the entire mechanical biological waste treatment facility itself needs. At the end of the water treatment process, purified water, water for agricultural irrigation purposes, or nutrient-rich liquid fertilizer are all available. In addition to water management, the ZAC also sets new standards in exhaust air purification. Biofilters are containers filled with natural substances, such as bark mulch. The microorganisms in the biofilter reside on the biofilter material. The polluting substances in the exhaust gases are absorbed by the microorganisms and are then broken down biologically into carbon and water vapor. Step 4. Biological drying. After the separation of water from solid just completed, some microbially assimilable organic material remains in the solid material, thereby biological drying to take place that is both energy-saving and economical. In tightly sealed concrete tunnels, air passes steadily through the waste, providing the microorganisms with oxygen. These microorganisms feed on the material's organic components and produce heat energy for drying. After a brief treatment period, the homogeneous dry and fine solid material is available, which can subsequently be easily broken down into its constituent components. Step 5. Mechanical material separation. Screening and sifting systems then break down the material from the biological drying process and actions. Energy-rich combustible materials, as well as minerals, are transported through special conveying systems to the loading stations and can be dispatched without requiring any further treatment. The goal has, at this step, been achieved. Economically utilizable raw materials and high obtained from waste material in industrial processes, which can be used to replace fossil fuels like coal and crude oil. What happens to the high quality are the energy-rich substitute fuels can then be used in industrial coal-fired power stations to generate electrical and thermal energy. In the nearby combined heat plant in Pforzheim, Germany, up to 20,000 tons of hard coal, or about a quarter of the plant's requirements, could be replaced by substitute fuels, which equals approximately 5 megawatts. Another customer for the substitute fuel produced is a regional paper manufacturer. At the truck docking station, the material is then transported via screw conveyors and conveyor chains to intermediate. From there, the RDF is transported pneumatically and blown into the combustion chamber of the circulating fluidized bed boiler. The household waste sourced RDF substitutes imported natural gas, oil, or coal. In a rotary kiln of a major cement manufacturer, the RDF produced by the MYT plant is burned at high temperatures between 1500 and 2000 degrees Celsius at the flame, thus achieving complete destruction of organic matter. The residence time of the fuel in the furnace is longer than 2 seconds, and therefore in full compliance with current legislation. A neutralization of the acidic gases of the fuel is achieved by passing the gases on over quicklime in the kiln. Emissions at the chimney are continuously monitored by devices connected to a computer system and are communicated quarterly to the appropriate environmental control agency. The fuels produced from waste conserve resources and reduce carbon dioxide emissions, which is good news for the environment. The products created by the MYT process clearly illustrate the great potential that exists to create energy and raw materials from household waste with minimum impact on the environment. In addition, dependence on oil, gas, and coal imports is minimized, and a positive contribution is made in the effort to prevent climate change. See for yourself by visiting the ZAC in Ringsheim. MYT can be seen up close by the people and is waiting to be explored and marveled at. The facility.
Yeah, this is just the area around that. Yeah, I hope this video was quite good understandable and was also good flowing from the pictures. So if you wanted to see it again in high quality, you can, as I said, just visit our YouTube channel. But I hope this was informative for you. And with that, I want to end my presentation for today.
Situated amidst nature.
Thank you very much, Marc, for that very extensive presentation. And the quality of the video was actually served very well the purpose.
Okay. Good. Yeah, because I already had the experience that when you get on higher quality, then the other persons only see like stop motion.
Yeah. Okay. So thank you very much. So we are at the Waste Summit 2020, and maybe if you stop sharing your screen, Marc, we will see all the faces of the participants. And this is the Waste to Energy Summit, and we have now come to the Q&A session. May I suggest that if you have a question, that you basically write your name in the chat box, and then I can call on you. You may also write what you would like to ask about if you want, but just give me an indication. that you would like to have the floor, and I'll try to give you the floor. I thought maybe just to kickstart the conversation, I start with a couple of questions, and then we get others to come in. So first of all, maybe back to our first presentation from Sajith and the Chipmunk EcoCycle. You presented that you thought of industrial waste, and I mean, you say more or less that you can take very many different kinds of waste, but could you say something more about what waste can you not take, and like what kind of waste composition would this be a solution for Cambodia for, and what kind of waste can this process not solve?
Yes, thanks, Leif. Basically, I will tell what are the things that we cannot take, because if we are going to say that what we can do a lot of things, a lot of waste.
Okay.
So rather than saying what we cannot, basically we have some banned waste, I mean negative waste list that we are not going to take. In the Basel Convention also it mentioned clearly. So one thing is the radioactive waste, no. And electronic waste we are not going to use in the cement kiln processing. And like whole batteries, and like biological medical waste, asbestos, this kind of waste we are not going to take. It's like 8 to 10 waste streams that we are not going to take into cement kiln composting due to 3 reasons. One is actually if those waste which we cannot, if those waste will impact to our employees who are managing that, so then we are not going to take that waste. And if that waste is impacted to our cement, our main product is cement production, so that we are not going to take. If there's a waste that we cannot manage the environmental harm with that waste, then we are not going to take. So, but if you look at the industrial waste spectrum, 95% of the waste which we can take.
And about organics waste, I mean, what is the situation? I mean, can you take all types of, or I mean, can you take all organic waste, or is there limitations on that?
So in the RDF fraction, actually, as clearly mentioned by Sebastian also, there are, because most of the plants in the cement plants are using, you can see like in Europe and all these countries, they have substitution of 50-60% of RDF fractions also. Those things we can use basically, but at the moment we are not, we don't have here, so then we are not using at the moment.
I was hoping now there was going to be some action in the chat box, or if somebody would use the function of raising their hand, that's also possible. But so far I haven't seen anyone do that. Oh, I see one hand there. Sarun Mong, would you like to ask a question?
Okay, thank you, Mr. Holmberg, giving me the time for the question. Actually, before I read the question, I have some comment on the waste separation in Cambodia in comparing to the Germany, especially to the last presentation of Mr. Loskarn, because Cambodia is, you see, we have a lot of waste from household, and then even the Cambodia government, they have some legal background to bring the people to understand the waste separation, but it's not much effect at all, because if the Cambodia, they can separate the waste, and then the only one car, trash car, they come and collect, and they put the same car in, I mean the 1 or 2 waste separation back into one car, and the same, you know, not affect at all. And is comparing to the oil well about the MYT technology, very high tech and work very effective for the waste separation, and you have a lot of 5 steps of the waste treatment. I think that it is very high tech comparing to Cambodia. We have no chance to do. But I just want to ask a question that, do you have any small scale, like your processing here, maybe the Cambodian or the businessmen, they have the opportunity to maybe buy very small technology from your company to apply in Cambodia? That's the question. Thank you.
Yeah. Thank you for your question. First of all, exact the same status that you just mentioned, we face in Thailand at the moment, because they are also implementing some separation at source legislation in Bangkok itself, in the city. But as you already said, they are more or less just putting it together in one car again, and then it's mixed again. But for our technology, because the pre-treatment is like an independent step. So the pre-treatment, the mechanical pre-treatment, so sieving and mechanical separation is one step, and you then put other steps behind it. So for us, the mixing of waste is totally okay, because we separate it in a suitable quality for us. And I will tell you tomorrow a bit more about other not so high-tech technologies, which are perfectly working in Egypt, in the MENA region, in Eastern Europe and Asia. We have lots of references here, which is only a pre-treatment. So, and then with open heap composting or bio-drying, with membranes, with bioboxes. So without the production of biogas, which is here obviously the most demanding technology, with measurements, with extra legislation, so explosive of methane. So we also have other technologies which are probably also suitable for you, and especially for Cambodia, to separate the mixed waste and then get RDF and organic separated out of it.
Thank you. We go further to a question from Kolyan Chuorn. You have written the question in the chat box, but I would actually suggest that you unmute yourself and you turn on the microphone, and maybe you can ask the question orally, please. Kolyan.
Thank you for the floor. This is Kolyan from Cambodia. I think my question has already been addressed by Mr. Monzeran already. I just want to have the viewpoint and the perspective from our speaker regarding the current Cambodian waste practice, the management, as well as the infrastructure and also the legal framework Cambodian has. So I would like to ask to our three speaker, is it wise for a Cambodian government to invest in such high-tech in terms of the capital expenditure for such investment? Thank you. That is my question.
So anyone would like to say something about this?
Well, maybe I could answer, if you don't mind, that I think that this technology, it looks very sophisticated in this video, and of course it is an advanced technology. But we should not be scared, I think, to say this is too high quality. This is not possible in a Cambodian context, for example. What Marc Loskarn said, and this was also one question from my side, right? It is already implemented now in Thailand, yeah, with very similar conditions also from the waste quality sector. So this proves actually that there's a business model behind that can work also in Cambodia. And this Thailand facility, it treats, I think, if I'm not right, if I'm not wrong, Marc, it's about 800 tons per day, right? So it's really a huge amount. It's not a small facility. And there was an investor. They are operating partners. The cement industry in Thailand was or is involved there, and this proof of concept. This I found. I visited the plant twice, so I've really seen it, and I found really convincing. And one aim also for the whole summit, I would say, is to find out what we can do to also make it like a business model for Cambodia. So I would not be scared too much of this technology. I would say it's a rather it's advanced, but still rather basic. No? Yep. It's not a very complicated technology.
Yeah, it's all known technology. So especially mechanical treatment is a basic treatment. The specialty here in Germany is that the waste is totally enclosed and it's really clean there. So it also makes the people enjoy it working there. So which is also probably a fact that should not be underestimated. And the technology is working. It's proven here in Germany and in other countries. And if it's good, if it's good operated, then you don't have any problems for the next 20 years. Usually.
What is your opinion there, Sajith, from Chipmunk perspective?
Yeah, basically, as a Chipmunk, what we are thinking is, yes, in Cambodia, one of the main challenge that, as Mr. Mong explained, basically the investment part, because so for us actually we have an advantage because with the cement plant we have the cement kiln is already in place, which is we have already the infrastructure built. So in terms of the investment part, if you're going for the municipal solid waste, so the tipping phase and those things are the main important aspect in this kind of countries. So which is quite challenging part in Cambodia. If we can address those parts, and there are, yes, if you look at the RDF part, actually yes, there are cement plants are there are some industries are there which we can get some of the some good customers. I think can do, but there should be some legal frameworks and things has to be established, and some polluter pay concept has to be established. That will be a success part when you're going to implement this kind of solutions.
Okay, I would like to give the floor to Eric Busman as a question.
Yeah, thank you very much all for these very, very interesting presentations. I think indeed in Cambodia we should not be afraid of these relatively high-tech solutions. But it comes always down to, like what you also said, Sebastian, what is the business model? How can we recover costs, right? So if you look here in Cambodia, I mean, with biogas we can generate electricity. I'm not sure with that maximum yield technology if you also generate good compost, but that could potentially be another source of income. But are these two sources enough? So maybe it would be a bit interesting, maybe you could explain from your experience how in other countries these plants have been made financially viable. I mean, like in Europe, you have the challenge, I mean, waste has a high cost, right? There's no landfilling. So how to get rid of that waste? So that has a cost. But like here in Cambodia, the cost of landfilling, the tipping fees are very low or even non-existent. So in such an environment, and then also the scale is another issue. I heard 700 or 800 tons per day. I mean, that's something we only have here in Phnom Penh. But in secondary cities, you would look at 100 ton per day, more or less. So with these constraints and issues, where do you think the opportunities are?
For the capacities, as I said, the plant in Germany is only like a third of the plant in Onut in Thailand. So it's 100,000 tons a year. So it's roughly 200 to 300 tons per day. This can also be calculated for less amount. So I'm not, at the moment not sure what is the minimum amount we need, but 100 ton per day could be possible. So this shouldn't be a problem. For the financing, you're totally right, because in Germany, the tipping fees are pretty high because of the landfill and the area leakage here. This is the main problem probably for Cambodia. We in Germany, so the concept is we have the tipping fee. We need around a minimum of 10 US cent per kilowatt energy as a fee. And of course, we have the highest fraction is the selling of RDF in different qualities. So depending on clients, so cement plants or paper plants or what you've seen, power plants, it's connected to different quality treatment equipment. So the higher the required quality is, especially for compost. So compost is possible to make, but it's very expensive because you really need to have a good separation of the organics and the plastic, because at least in Germany and other countries in the world, it's prohibited to make compost with 1% or 2% of plastic particles in it. So this would be here the challenge, which is not impossible, but it is of course connected to costs. So I think compost is not suitable here for Cambodia, but rather to make a lower calorific RDF fraction of it. So dried organics and also plastics in it, like we did in Onut in Bangkok. So we are not producing any compost or soil improver here because of the required standards. And to make this possible, that it's still financing itself, we are only producing RDF here for the cement industry.
I think that one of the major obstacles for any of these waste to energy solutions that one can discuss, including the examples that you're giving, is exactly the whole financing part. Given the sort of who is going to pay for it, it's the fundamental question. And I think that is something that's where we have a very different situation between Cambodia and Europe. And when one look into all these kind of possibilities, this is a key question. But I would like to frame another question related to that to all three of you. What kind of regulatory challenges do you see for your different technologies to be adapted in Cambodia further? What is the regulatory challenges that you think needs to be addressed to get more waste to energy to work in Cambodia? Maybe would you like to start, Sajith?
Yeah, basically, I will explain about the relevant to us. Basically, you know, in Cambodia, waste management industry, I'll explain as an industry, waste management industry. You can see, I saw that in Sebastian presentation, 70 billion worth of industry is the waste management. But if you look at the Cambodia, it's like it's not like that. So basically, at the moment, there are some regulations are in place in Cambodia, but those are not executed. So one thing is execution has to be there, but for the execution also there should be some facilities to execute. infrastructure to execute. So therefore, it's like a chicken egg situation also. That's why we jumped quickly, even though there are some executions are not there. But as a cement player, if you look at the investment wise also compared to the other investment for the waste to energy or whatever the things, we can do some minimum investments and then we can start. So that's why we jump first and then start to prepare the platform to others also to enter. So because main challenge is the tipping fee. So if we, any of the investment, if you want to be the viable of any investor to come, has to have some decent tipping fee. So here Cambodia, even not only about the municipal solid waste, even the industrial waste also quite challenging to get those tipping fee. With the last few decades, there's a ample of lands are there and unmanaged landfills are there. They can easily throw away the trash, and then now if we are going to ask the tipping fee, then it is a burden for their income statements, and therefore nobody willing to pay. So it is a process. I know it's a process. It's a process like this kind of countries. So we have to have some investors has to come, and then have to have front runners. Front runners in this sector. Then the government also has to execute the laws that they have at the moment. So then it will help. It will help to develop the industry. And on the same time, for the new waste players, there should be some concessions and things has to be come.
Thank you. What about you, Sebastian? Do you have something to comment on the question?
Yeah, it's all about finance, right? As Eric also said, it's about the business model and then hard finance. And one income source also to finance waste management, and we will learn this in the next days also in the summit in this week, is the so-called EPR regulation. So extended producer responsibility. That means that the generators of, for example, the packaging waste are financially contributing into a system. And this actually in Germany, through this EPR system, about 1.2 billion euros are collected from the government, from the generators of some waste streams. Yeah, so it's the polluter pays principle. And multinational brands like Unilever and Nestle and Coca-Cola, they are more and more aware about the situation. And sometimes even they are the driving force behind this regulation. And this is something that we would also like to discuss in the next days. But I think this is one financial element to support modern waste management, not only on the waste to energy sector or RDF sector, but also when it comes to recycling.
Marc, anything to add? Okay. I see that we are already 10 minutes on overtime. So
Leif, actually, I just want to clarify, because you asked second question from me about the organic fractions, which is actually, I want to be fair to the audience. Basically, the Marc solution is actually the one of the best solution rather than this co-processing. And yes, we can dispose, but we are always respecting in the waste management hierarchy, and why you don't want to send it to the cement plant. So all the fractions, basically the composting, biogas, actual biogas, those are the perfect solutions for those things, right? Sorry about that.
No, we should never forget the waste hierarchy, and that's I guess why at least two of you had it. Had this picture in your presentation. That's always at the forefront of the waste management work. So there is one question here from Claire Baker Mouton, which is about the sufficient volumes of waste and the high enough calorific value. But I actually think that Marc Loskarn was answering that just before. So I think we already have talked about that. and I think we are about 10 minutes over time already. And then the last question is, how should we mobilize citizens and consumers regarding this? And maybe as a closing for this session, I'll just give each of the presenters a minute to so to say, give a pitch for why waste to energy is such a good solution for Cambodia. Who would like to start?
I can start if you like, Leif. So, first of all, events like this, like what we're having now, to create awareness that waste to energy is not a bad thing. So, of course, there's this this effect that's called "not in my backyard," right? So people want a clean environment, but please do not treat waste just next to my or in my neighborhood. And this is an issue in many countries, but also in Germany, I can speak that we have, for example, one RDF facility in the city of Berlin, just in the middle of the city center. It's just 6 kilometers away from the German parliament, and it's put right in the city center. So, but it needs awareness and it needs good technologies, of course. So there are some very negative examples of bad exhaust and flue gas treatment. It needs some standard and some level, technical level, to implement good and clean waste treatment facilities. But if we have this, then consumers and citizens should not be scared about this. And also we need to mobilize business models, business models how to operate this. And a good and promising start, in my opinion, is the Thailand approach for Southeast Asia, and we hope that this will trigger also projects in Cambodia.
Yeah, basically for me, actually, I want to highlight 3 things. One is actually, yes, in the waste, you have a lot of money inside, which we have to extract. That is first thing, which actually Sebastian said that have to have some high technologies, good technologies, and people, good business models. So basically, another thing is the people who are coming to the industry has to have a stamina to stay in the industry, because it is not, you cannot make like a money like a 40-50% of the returns within 1 or 2 years, which you cannot do. So there should be a stamina, and because this kind of countries is in the introductory stage of the waste management, therefore we have to have a good stamina. Another thing is the government and private party has to work hands in hand to win this battle. If we win the battle, actually it's like a lot of money inside the waste.
Marc?
Yeah, I think just to get to this problem, a lot of educational work is also needs to be done from school to universities, to all of the participants in the system, also the scavengers and all people there in the country, because they need to to get it that waste is a resource. As we say it here in Germany, we use it as resource for energy, for metals. Of course, like you all probably already do with the scavengers. So they are just picking doing cherry picking out of the waste, which is easy to get, like electronics and copper stuff. But we need to get to make them aware that more energy and more resources are in the waste, and we want to use it. And of course, incineration is not the waste to energy is not the only possibility, but it's one way to get to our targets in the future. So we need also to combine it with other technologies. So there is no one technology. So we need, of course, also focus on recycling, but we need also to have a lot of waste to energy here, because this is also beneficial for all the people there to get more cheap energy then.
So this last question, based on what you had written in the chat box, and I took the freedom to rephrase it a bit and to have that as the final question in today's discussion. So with that, I'm saying thank you to the panelists for today's discussion. So this is the 2020 Waste Summit, and this is a whole week of different activities, different presentations, different discussions, different online meetings, but also some study visits that are included in the program. And I would just like all the participants here today to really look into the agenda to see what other interesting sessions that are sessions that are interesting for you, and to then ensure to participate. I think it is even possible to do a study visit to the chipmunk eco cycle, if I'm not wrong. So that's for instance, one of the possibilities. And the program continues tomorrow at 9 o'clock with a focus on the organic waste. And then we are going to hear, among others, presenters from Comped talking about organic waste management, which is obviously a key issue given the high percentage of organic waste in Cambodia. So I would just like to check with my colleagues from CAS. Kitty, do you have anything to add, or anyone else from CAS who would like to add anything before we close today's? It seems like all is good. So then I would just like to thank all the participants for today and look forward to see you in the coming days on the Waste Summit. So thank you very much.